All right, everybody. It's time to pay attention. We're doing notes. If you're not done with the warm-up, just leave it there. Open a new tab, but stop working on it. We're gonna go. We're gonna do notes. 10.1. This is our last unit, Unit 10. And Unit 10 is on recursion, which is when a method calls itself. Well, thank you. It might sound like a bad idea for a method to call itself, but it's not. And there's some very interesting problems where when you set it up with recursion, it's quicker and more elegant. And in fact, both of those problems we did in the warm-up, we could do with recursion, and we will do one of them today with recursion. So recursion, a recursive method has two properties. One or more calls to itself, and two, a base case, which is something that's checked each time through, so it can say, oh, should I bail out of this loopingness, or should we keep looping? Otherwise, it will loop forever. So you can make a loop forever situation, and then Java just crashes. So I'll show you. Here's an example. In fact, here's the factorial problem. Public static int factorial int n. If n is 0, we return 1. I don't know if you guys knew that, but mathematicians defined factorial 0 factorial as 1. So whatever. 0 factorial, return 1. Otherwise, return n times the fact you're calling the function again, but with the next lower number. See that? So here's the base case at the top. If n equals 0, return 1. And then here's the recursive call, calling itself, but with a different number. If you called it with the same number, it would loop forever, and it would say you can't do that. Yeah.
So it goes until n is equal to 0?
Yeah. Yes.
So does it stop at 4 0?
Does it stop at what?
So does it stop at 1, or where does it stop?
This would stop at 0. If you said factorial 3, it would end up doing 3 times 2 times 1, and maybe another times 1, because when it sent 0 over, that would be times 1 again. But yeah.
So would it show all the steps?
Nope. It would just pop out the answer. It's crazy. This is the call to itself, and that's the base case. There, I highlighted it all nice. So let's walk through this, and this may or may not help. It seems really complicated, but it's not that bad. If we called factorial 4, here's what happens. 4 is not equal to 0. So it's going to call 4 times factorial 3. And when we do factorial 3, we come in, 3 is not 0. So that one calls 3 times factorial 2. And 2 is not 0, so it calls it again with 1. 1's not 0, so it calls it again with 0. And 0 is 0, so it returns a 1. And then look at what's going on. It's 1 times 1, and then it'll be times 2, times 3, times 4. It's all just sort of queued up. And so we got 1 times 1, and then we got 1 times 2, and then we have 2 times 3, and finally we have 6 times 4 is 24. And I get it. You know, there's a lot of...
So you started with 24.
I started with the number 4. I sent 4 over. And it's going to return, it's going to print or return, it returns the number 24. So this is, it literally goes through this process. We start with 4, and it calls the 3, and the 3 calls the 2, and the 2 calls the 1, and the 1 calls the 0, and then it backs them all up. Now that it's done looping, like they're all kind of stored over here on the side, and then it multiplies them all together and returns 24. Just all, it's like magic. Yes? Yeah.
So it returns.
Or in a problem this small, probably the same, but in a bigger, more
So
complicated.
it returns 4 times 3 times 2.
It returns 4 times 3 times 2 times 1 times 1.
Well, just 4 times 2 times 2.
Yeah. Here's another example. Check this one out. let's see if we can figure out what it's going to do. Send over a number. It prints out that number plus a space. And then it says, hey, if n is still greater than 0, then we're going to return, then we're going to call ourselves again, but with a number that's 2 less. So if we call 5, call it with 5, 5 gets printed. And then it's going to, okay, great. Yeah, no problem. 5 gets printed. The base case is checked. 5 is greater than 0, right? So then it's going to call it with 3. 3 gets printed. I'm showing you what's being printed here. Then the base case is checked. 3 is greater than 0, so it calls it with 1. 1 is printed. Base case is checked. 1 is greater than 0, so it's going to call it with -1. And I had to make some of my explanations small. -1 is printed, and then it checks the base case. And since -1 is not greater than 0, it doesn't loop anymore. It's just done. Yeah.
So the through line is after the return line?
I have that next.
Then it would be
It-
531.
It would be actually it would be -1 135. It would print in the opposite order, but we'll see that in a sec. Questions about this? Yeah.
So how is it like looping without a for while loop?
It's calling itself right here. Recurse is the name of the method.
So it's passing, like, let's say you entered, I don't know, 5
Yeah.
as in n, so then it would be,
Yeah. You enter 5, and then it calls it with 3. See right here, it prints a 5, and then it calls recurse 3. And when it comes in with a 3, it prints a 3, and then it calls it with a 1. And then when it calls it with a 1, it prints 1, and then it calls it with -1. And then I know it's weird that these got smaller, but I needed it all to fit. And when it prints a -1, and then -1 isn't greater than 0, so it stops. So I mean, why do you need this? Whatever. It's just to show you how it works. And problems like this can show up on the AP test where you have to say what would be printed. Here's another example. You've heard of Fibonacci numbers. There's different versions of the Fibonacci sequence, but my favorite starts with a 1 and a 1. And then after that, every additional number is equal to the previous 2 numbers added together. So you can do this very easily with a recursive function. Not very easily, but I mean, here it is. It's 3 lines of code. If I ask for the first Fibonacci number, I get a 1. That's the base case. If I ask for the second Fibonacci number, I get a 1 also. That's what this is. If I ask for the third one, it says return the previous 2 numbers added together. Like if I send over a 3, it would call it with a 2, and it would call it with a 1, and we'd have 1 plus 1. We get a 2. Anyway, it's an interesting.
Wait. Wouldn't it return a 3?
Nope. If you send in a 3, it calls it with a 2 and a 1. And then when you get a 2 and a 1, that's the base case, and it's a plus sign between them.
yeah.
So it's just 1 plus 1. If you called it with 4, the number we're looking for is a 3. It would call it with a 3 and a 2, and the 3 would call it with a 2 and a 1, and yeah.
But since the return isn't like in an if statement, this would just execute once? Or would it?
No, look, it's calling itself twice. This seems like quite a chain. You call it with the number 5, it's going to call it with 4 and 3.
Okay.
And then the 4 is going to call it with 3 and 2, and then the 3 is going to call it with 2 and 1. I mean, they're all going to do their little things, and then they all ripple back up, and you get the answer.
Wouldn't it never get to the second call for Fibonacci? Because the first time when we call it just restart and then go back to the top with a different number?
No, it kind of saves everything over on the side,
And then it just
and then it adds it all up.
pretty much can do multiple.
When they all kind of ripple out, and then they all come whooshing back in. I mean, we don't have to worry about like how would we. This is not how we would do it as a human, but I wish I had a little tree on this. Like if we called it with the number 5, we should get a 5. 1, 2, 3, 4, 5. Meaning if I wanted the 5th Fibonacci number, call it with 5. It's not 1 or 2, so we're going to call it 4 plus 3. Fibonacci 4 plus Fibonacci 3. But Fibonacci 4 is going to call it with a 3 and a 2. And the Fibonacci 3 is going to call it with a 2. And the other one, but then sooner or later, the base cases will get hit on all these little branches, and then we'll just have numbers coming back, and they'll be added up, and it'll wrap itself up. So it's, gosh, that's horrible. I love that. Here's one. It counts down from whatever number you send in to 0, printing each number on its own line, right? If we send over 5, it prints a 5, and then it calls it with a 4 and a 3 and a 2 and a 1, and finally even the 0 prints, and then if n is greater than 0, it keeps going, and if n isn't greater than 0, it's done. But check this out. If we put the print after the base case check, this is the exact opposite. It'll count up from 0 to n because it waits to do any printing until it's through looping. So I'm wondering, I walk us through it. So here we go. We call it with 5. 5 is greater than 0, so we call it with 4. But nothing's printed yet, but we know the 5's going to get printed sometime. We call it with the 4, we call it 3, call it with 2, call it 1. And finally the 0 happens. No more recursion, and then it bounces back up, and it's going to print. Is it going to print a 0? Yeah, it'll print a 0, and then it bounces up. It's going to print the 1, and the 2, 3, 4, 5.
So why does it?
Insane. It saves it over on a little. It makes it. I don't know the correct term. Is it a stack or something? So the key here is if the print is before the base case, then it'll go in the order you imagine, just linearly. Okay, we're going to print a 5 and a 4 and a 3 and a 2 and a 1 and a 0. If the print is after the base case, it doesn't do any printing until it's done with all of its recursion, and then it prints backwards. Yeah.
So if the print was before the if, then would there be a -1?
No, because this is if it's greater than 0, right? Yeah. Good question. Hey, let me just give you guys a tip. It's a good idea to trace these out on paper. I don't mean trace them like a picture, but that's what I do. And this isn't success. If you want to do well on the AP test, which I think most of you want to do, then you should try to get it right. And it's not about, oh, I know what this is. So you could write it down on paper. Sometimes they're really complicated, and you write down the things, and then it's not as bad as it may seem. Like I said, if the print call is after the base case, then it's probably going to go in reverse order. If the print call's before the base case, it'll probably go in the order that it's happening. And there is no single rule, though. Rest of today, I want to do the first 2 coding bats together. So let's do that now. Can everyone log into coding bat? And then I have 4 quick REPLs, and then you'll have a couple more coding bats. So. Well, each one is like 3 lines of code. Yeah, so I have 4 REPLs where you have to write 3 lines of code, and you're going to be okay. It's going to be okay. Let's open up coding bat. If you say so, Mr. Hayes. I say so. And I am still recording, and I think that's okay. We'll go ahead and you all log in. I'm not going to log in so that my answers are not already showing. So recursion 1. I want to do the first 2 together, and then I'll post all those REPLs that you can get to work on. So let's do factorial here. It was already in our notes. I'm going to make the text as large as I can. So it says given n of 1 or more, return the factorial of n, which is n times n minus 1 times n minus 2, all the way down to 1. And we have to do it recursively without loops. So, what does the recursive function have?
Base case.
We have a base case, and then we have a recursive call. So, base case. How many of you are already in coding that? Okay, I'm gonna go for it. So base case, if n is 0, turn 1. That's we've gone all the way to the bottom of the chain. Otherwise, let's multiply n, return n times factorial n minus 1. It's literally that simple. Unless I made a mistake, but let's go ahead and run it. Bada boom. And there's a hint on this one. Do the base case and then dot, 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 dot. Yep. So I get it. This is brand new, and I don't expect you all. That's why I thought, let's do 2 of these 6. The next one has to do with rabbits. Wabbits. And it might seem scary, but it's actually the same sort of thing. So get on to bunny ears, please. We have a number of bunnies. Each bunny has 2 big floppy ears. We want to compute the total number of ears across all the bunnies recursively without loops or multiplication. So how about this? They're sending us how many bunnies, right? I think, anyone want to take a stab at the base case?
If bunnies equals 0, return 0?
Yeah,
0.
if bunnies equals 0, return 0. I mean, if there's no bunnies, there's no ears. Otherwise, check this out. Return 2 plus bunny ears, bunnies minus 1. So if there were 4 bunnies, it's going to do this when bunnies is 4, 3, 2, 1, and it's 2 plus 2 plus 2 plus 2, and we're going to get 8. It's kind of crazy. We're not multiplying. You could have just multiplied bunnies times 2 and returned that number, right? But they're asking you to do it recursively. So you can go ahead and cheat on this, but when we have a test on this on the Friday before spring break, you're gonna get smackdown if you just don't do these the way I'm asking, which is with recursion. I think that's right. Yep. So let's see what happens just for kicks if we don't do the minus 1. I think Stack Overflow error. That means it looped forever. Like it caught it. It was an infinite loop. That's you got to have something change. Something has to change each time through. And what we were changing was the number of bunnies. Every time we added 2, we took 1 off the bunnies, and then we get we're taking 1 bunny out of the situation. Yeah. So I'm there's a truckload of these assignments coming.
So is that all the coding that we're doing?
Nope. I want you to do the next 4 also, but you don't have to do them first. You can do them in the coding bats. The rest of the last 4 are due by the start of class next time. I'd like you to do all the repos right now. So set coding bat aside, and I've got 4 repos I want you to do.
All those repos are due 30 minutes ago or next?
They're all due today when class ends. So let's get on the repos, everybody. Google doesn't let me post things due in the past. Yes? Got what wrong? Today's 72. It's okay, yeah. I mean, in my world, it's 72. Feels pretty good to be in my world. All right, I'm going to stop recording.